continue with our chemistry chapter. So today we are going to start with stereoisomerism. Stereoisomerism in detail it is not given in your 11th standard syllabus, but what is this stereoisomerism, that alone we will study. Okay, the definition alone. So as I already told you yesterday, stereoisomerism is divided into two types: geometrical isomerism and optical isomerism. About these two we will be studying in 12th standard only in detail. Okay, so now we will just see what is stereoisomerism and what is this thing. So stereoisomerism means the arrangement of the atoms in space. The arrangement of atoms in space. Okay, so same atom only, but it will have different arrangements. Same atom, it will have different arrangements. For example, butene. What is the formula for butene? But means how many carbons? 4 carbons. In second carbon there is ene. So second carbon ene means double bond. So remaining all is single bond. So what is the formula? CH3, CH, CH, CH3. So I can write it as CH3, CH, double bond C, H, CH3. Yes or no? Now I am going to write this molecule in two different arrangements. You see how I am writing? So the C double bond C I am writing in the middle. So H, then CH3, then this H and CH3. This is one type of arrangement. Another type of arrangement I am writing like this: H, CH3, H, CH3. What is the difference? Here the similar groups are in the, suppose if I divide this atom like this, similar groups are in the same side. Here similar groups are in the opposite side. So if the similar groups are in the same side, we will call it as cis isomer. And if the similar groups are in the opposite side, we will call it as trans isomer. So what is cis isomer? Similar groups in same side. Again I am telling, both of these are same molecule only. Butene both are butene only. But because of the different arrangement, it is showing two different isomers. So cis means similar groups in the same side. Trans means similar groups in the opposite side. Similar groups in the opposite side. Okay, understood? So now, since this is cis, it is called as cis butene. This is called trans butene. Cis butene and trans butene. Next, organic reaction mechanism. Organic reaction mechanism. Organic reaction means what? Organic reaction means the reaction is going to happen between two organic compounds. Mechanism means we are going to explain that reaction in a stepwise manner. So what is the organic reaction mechanism? Definition they will ask. Organic reaction mechanism means the sequential steps that takes place when organic compounds means carbon compounds, undergo chemical reaction. When organic compounds undergo chemical reaction. Okay, so the organic substance will be there, or the organic molecule will be there. Okay, so usually in chemical reaction, what we will say? We will say it as a reactant. Yes or no? But in organic reaction, we will call it as substrate. What is the name given? Substrate. Okay. So usually when you write a reaction A plus B giving C plus D, you will call this as reactant. This is product. Yes or no? In organic chemistry, this is called as the substrate. Now, when the substrate is attacked by some molecules, we will call the molecule as the attacking molecule. What it is called? Attacking molecule. So when the substrate is attacked by a molecule, it will not form a product. Okay, so as I already told you, it will undergo many stepwise reactions. So all the stepwise reactions are called as intermediates. It is called as intermediates, or it is also called as byproduct. From the byproduct only, the last resultant product is formed. Okay, so this is the organic reaction mechanism. So in the next lesson, organic chemistry, we will be studying many mechanisms. Okay, now we have to know what is a mechanism. Next one, fission of a covalent bond. Fission of a covalent bond. Again I am telling, these are all basics. We will use all the concepts which we are studying in this lesson in your 11th standard and 12th standard organic chemistry. In the college also, if you take chemistry, there also you will study. Okay. So fission of a covalent compound. What do you mean by fission? Have you heard of the word fission? Nuclear fission, nuclear fusion. Fission means breaking. So breaking of a covalent bond. What do you mean by a covalent bond? Covalent bond means the bond which is formed by the sharing of electrons. In 10th standard carbon and compounds lesson you have studied. The bond which is formed by the sharing of electrons is called as covalent bond, and how that bond will break, that we are going to study. So there are two types of breakage. The first one is called as heterolytic cleavage, and the second one is called as homolytic cleavage. Heterolytic cleavage and homolytic cleavage. First we will study what is a heterolytic cleavage. Okay, heterolytic cleavage. Heterolytic cleavage, I will diagrammatically first I will represent, then I will give some examples. Suppose AB is a covalent compound. Covalent compound means what? This bond is a covalent bond. Cleavage means what? This bond is going to break. So heterolytic cleavage means this two electrons which are present in the bond, it will go with any one atom. So these two electrons can go with any one atom. So what we will get? We will get A plus and B minus. Okay, so this A is not having any electrons, so it will get one plus charge. Okay, so this B already it has one electron. Now A's electron also is coming to B. So it is getting one extra electron, so it will get minus charge. So these type of bond breaking is called as heterolytic cleavage. For example, CH3Br. So what will happen is this Br will take both the electron with itself. So what will happen? We will get CH3 plus charge and Br minus charge. CH3 plus charge and CH3 minus charge. Here the carbon is getting the positive charge. Positive ion means cation. Here the carbon is getting becoming the cation. So this is called as a carbocation. Carbocation means what? Carbon with positive charge is called as a carbocation. Okay, so CH3 means what is that? Methyl, ethyl, what is that? One carbon.
Methyl.
So it is methyl. So this carbocation is called as methyl carbocation. Methyl carbocation. So in this case, what is the carbocation you will get?
Ethyl carbocation.
This will break like this. So you will get CH3, CH2 plus Br minus. Carbon is having positive charge, so it is carbocation. So it is ethyl carbocation. Okay. So now the stability of carbocations. So which carbocation is more stable? Stability of carbocations. Which carbocation is more stable? Always the tertiary carbocation is more stable. Tertiary carbocation is more stable than the secondary carbocation, which in turn is more stable than the primary carbocation. So which carbocation is more stable? Tertiary is more stable than secondary. Secondary is more stable than primary. So what is this tertiary carbocation? What is this secondary carbocation? What is this primary carbocation? Okay. So I will draw three carbocations. Tertiary one, secondary one and primary one I will draw. You are going to tell me what is the difference. Okay. So first I am going to draw one tertiary carbocation. This is tertiary carbocation. This is secondary carbocation. This is primary carbocation. What is the difference? If the carbocation is having less number of substituted groups. Okay, here it is having only hydrogen, no substituents. Here instead of one hydrogen, one CH3 is substituted. Here instead of both the hydrogens, two CH3 is substituted. So if the carbocation is having more substituents, that carbocation is called tertiary carbocation and it is the very stable carbocation. Okay, and the primary carbocation, it will have very less substituents, so it is very less stable. Okay, it is very less stable. Less stable means what? It is more reactive. It is not at all stable. It will react immediately. Okay, with any other compound. Understood? So this is about heterolytic cleavage. Heterolytic cleavage means both the electrons in the shared pair will be taken by one single atom. So what is this heterolytic cleavage? So write the definition. Heterolytic cleavage means the shared pair of electrons remains on one fragment. One fragment. Fragment means one part. So two parts side is breaking. So if the electron will go to any one part. Okay. So next one is homolytic cleavage. Homolytic cleavage, first I will represent, suppose A bond B is there and this bond is a covalent bond. Covalent bond means two electrons will be there. Okay, so the bond will break in such a way that in heterolytic cleavage what happened, both the electron will go to the same atom. Here it is not like that. One electron will go to one atom and another electron will go to another atom. So you will get like this, A dot plus B dot. So the electron with the atom with unpaired electron, these are called as free radicals. What is the name given? Free radicals. Okay. So homolytic cleavage, free radicals are formed in homolytic cleavage. For example, if I take CH3X, so what will happen? CH3Cl I am taking. So Cl will get one electron and CH3 will get another electron. So I will get CH3 dot plus Cl dot. So here carbon is getting the free radical. So it is called carbon free radical. Here only one carbon is there. So what is this called as? Methyl. So it is called as methyl free radical. Methyl free radical. Okay. So in this case what free radical I will get? One electron will go here, another electron will go here. So what I will get? CH3, CH2 dot plus Cl dot. Here I will get ethyl free radical. Ethyl free radical. Here now we are going to study about the stability of free radical. Stability of free radical. So in carbocation, which carbocation was more stable? Tertiary carbocation was more stable. In free radical also, tertiary free radical is more stable than secondary free radical, which in turn is more stable than primary free radical. Primary free radical. Okay, so tertiary free radical means how I can represent? CH3, CH3, CH3. Here I should not put plus sign. Plus sign if I put, it will become carbocation. So I should put dot. This is more stable than CH3, CH, CH3 dot, which in turn is more stable than CH, H dot. Okay, understood? Next one, nucleophile and electrophile. Nucleophile and electrophile. What is nucleophile, Dhanush? Nucleophile means any species which is rich in electrons. Okay, nucleophile means and an electron rich species, or we can say a species which brings electron. Okay, when a reaction is happening, if any species is bringing electron, that species we will call it as nucleophile. A species that brings electrons is called as a nucleophile. Example, Cl minus, OH minus. So nucleophiles will have negative charge. They have negative charge. You have to write negative fully, don't write like this. Okay, NEGA, like that you have to write. The next one is electrophile. Electrophile is the opposite of nucleophile. It is an electron deficient species. An electron deficient species. It has positive charge. It has positive charge. Any examples for electrophile? NO2 plus. Okay, these are all examples for electrophiles. Electron movement in organic reactions. Electron movement in organic reactions. So, in what all ways the electrons can move in an organic reaction? Okay. So, there are three ways. Suppose one element Y is there. This side it is having single bond and this side it is having double bond. Or I am taking this side it is having double bond, this side it is having single bond. So electron, it can directly shift this side. Okay, and it can form single bond Y double bond. Okay, or the electron first it can go on top of Y. Okay, if it goes on top of Y, what will happen? It will be like this. Okay, because this bond has how many electrons? 2 electrons. So it will be like this. You can represent it like this or you can represent it like this as a negative charge. Okay, or the third way is the electron can go on top of this. So if it goes on top of this, it will be like this, and after going to the top, it can come here, this side. So you will get like this. Okay, so these are the three ways by which the electrons can be transferred in a chemical reaction. So we will see one example. Example, CH3Br plus OH minus. CH3Br plus OH minus. So OH minus, it is having a negative charge. Negative charge means it is an electron rich species. Electron rich species means what is the name of this? It is a nucleophile. So this nucleophile will go and attack this carbon. Okay, because you know how this bond will break. Yes or no? This bond, what will happen? It will undergo heterolytic fission, heterolytic cleavage. So this bond will break like this. So this carbon will get what charge? Positive charge. So this negative charged species will go and attack this positively charged species. So what will be the product? CH3OH plus Br minus. Okay.